Hello, this is going to be a video with some extra examples on calculating protons, neutrons, and electrons within an atom, and we may even go on and draw a couple of Bohr models. So if you're needing some extra help, some extra practice with these, then this is the video for you. So we did a few of these in class when we studied atoms, so I've chosen just a little snippet of some of the elements from the periodic table and included them on the screen. We're going to choose a few of those and talk about how to calculate these subatomic particle numbers. So let's start with boron. I know we did that one in some of our classes. So boron is the symbol B, and then we have two numbers in that box for boron. We have a 5 and we have a decimal 10.81. We're going to round that decimal to a whole number. That means if the digit to the right of the decimal is a 5 or above, we're going to round up. If that decimal digit is 4 and below, we are going to keep the number as is. This one is an 8, which means we're going to round the 10.81 up to 11. So these are the two numbers that we would be using for boron. Now the first thing that we want to do is identify what these numbers are. So the smaller of the two numbers, which in this case is a 5, is the atomic number. And the atomic number tells us the number of protons in an atom of boron. The other number that we see there is called the mass number or atomic mass. And this number is going to tell us the total of protons plus neutrons added together within an atom of boron. So another thing that is important to remember is that atoms have a neutral charge. So all atoms are neutral. We want to make sure we remember that. So what that means is we have 5 protons in this case. So we have 5 positive charges. In order for this atom to be neutral or have an overall charge of 0, we would also need 5 negative charges, and that's where the electron comes in. So every atom on the periodic table, we can look at the atomic number of that element, and that tells us the number of protons or positive charges, and it also tells us the number of electrons or negative charges, and that's because all atoms have to equal 0. So the only other subatomic particle that we lack in identifying is the number of neutrons. So the number of neutrons can be found by subtracting mass number minus the atomic number. So that's going to give us the number of neutrons. Okay, so in this case, the mass number is 11 and the atomic number is 5. So 11 minus 5 gives us 6. So here we have identified the number of protons, the number of electrons, and the number of neutrons for an atom of boron. Let's go ahead and get rid of these and try another one. Let's go ahead and try nitrogen. Nitrogen is atomic symbol N, and we see that in the periodic table square, our two numbers are 7 and 14.007. Remember, we're going to round that decimal to a whole number, so that's going to be 14. So our two numbers for nitrogen are 7 and 14. How do we get the number of protons, the number of electrons, and the number of neutrons from this information? Well, remember, the smaller of the two numbers is the atomic number, and that tells us the number of protons. Also, remember that all atoms are neutral, so that means that they have to have the same number of positive charges and negative charges. So what that tells me is not only are there 7 protons in nitrogen, there are also 7 electrons. Those equal 0. 7 pluses and 7 minuses equals 0. For number of neutrons, remember we are going to calculate mass number minus atomic number. So our mass number here is 14. atomic number is 7, so 14 minus 7 gives us 7. So in this case, we have the same number of protons, electrons, and neutrons for an atom of nitrogen. Okay, let's try another one. Let's go with, let's do aluminum. Aluminum is Al. The two numbers are 13, and we round 26.982 to 27. Okay, so number of protons is going to be given by the atomic number. I know that this is the atomic number because it is the smaller of the two, so 13. The number of electrons will also be 13 because all atoms are neutral, so the number of positives must equal the number of negatives, or the number of protons must equal the number of electrons. And then finally, for the number of neutrons, we're going to take the mass number, which is 27, and subtract the atomic number of 13. This will give us 14. So we have 14 neutrons, 13 electrons, and 13 protons in an atom of aluminum. Every element on the periodic table will work this way. You can find the number of protons, electrons, and neutrons the same method. Now, for the Bohr models, this takes it a step further and shows you the configuration of electrons. So Bohr models only show electron number, okay? See if I can scoot this up. I guess I cannot. Okay, so I'm going to have to erase something. Let's erase nitrogen and go with aluminum. Okay, so let's try the Bohr model for aluminum. So I will start by writing the atomic symbol, and this represents the nucleus of the atom. And then if you remember, we talked about 3 energy levels for electrons, or energy shells. And we said that the first one can hold 2 electrons, the second one can hold 8 electrons, the third one can hold 18 electrons. So these are kind of our numbers that we want to remember for energy shells. So if we draw the first shell for aluminum, we know that the first energy level holds 2 electrons. So 1, 2. I'm going to represent these with dots. Now we need 13 electrons. So I'm going to have to open up a second shell. And we know that the second shell can hold a maximum of 8 electrons. So I'm going to place 8 dots, or 8 electrons, in the second shell. Now, so far that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, and I need 13 for an atom of aluminum. So I'm going to open up a third shell, and I can put 1, 2, 3 electrons in the third shell. Now at this point I like to go back and double check to make sure that I have the correct number of electrons drawn. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 electrons total in aluminum. Okay, I'm going to erase all of this. Whoop, not with that. I'm going to erase all of this and give you one to try. So let's start with neon. Let's do neon. Neon is Ne. I want you to tell me the number of protons, the number of electrons, the number of neutrons, and then draw the Bohr model for neon. Go ahead and pause the video right now and try that, and then you can restart the video and see if you got it correct. Okay, so let's see what we can do for neon. Neon, the numbers are 10 and 20 when we round those off. The number of protons is represented by the 10 because that's the atomic number. Since all atoms are neutral, we know that an atom of neon also has to have 10 electrons. Then we need to calculate number of neutrons. Again, that is done by subtracting mass number minus atomic number. So it's 20 minus 10, which again gives us 10. Hopefully you got those correct. If not, you have plenty you can go back and practice those again until you start getting them correct. Now then, the Bohr model, remember, only shows electron number. So I'm going to start with the symbol. I'm going to draw the first energy shell. The first energy shell holds 2, so I'm going to put 2 electrons in that one. Then I got to go to a second energy shell because I need 10 electrons. How many does the second one hold? 8. Okay, so 2 in the first and 8 in the second does give us a total of 10 electrons. So this is the correct Bohr model for neon. Okay, if you have any questions or still need some help, please come and see me. I'll be glad to work with you on this. Again, you have examples in your notes and you have examples on this video that you can go back and work through without looking at the answers. Check yourself. And then, again, if you need extra help, just let me know. Happy studying.